Hello, welcome back. This is number 8 in this series of videos on how to set up a VAMDC Data Node. Now, let's look at the validation of the XML output this time. So we have the node deployed in the same way as we did in the last tutorial. So it's just running the same way there. Still an empty database. To run, you can validate XML by using the VAMDC provided XML validation tool, which is a graphical user interface tool. But we can also use a small Python script that is included in the Node software distribution, and that one needs the Python XML library, so we just install this here. Then we need the XAMS schema to validate against, so we download this from there. And once this is done, we'll see all the XSD files, which are the XAMS schema itself. No need to look at them, we just use them to run after we downloaded the same data XML file as we did in the last tutorial. So we see the same query here to our node, and we see that it's empty still. So we get back the empty data XML file, looks just like last time. And now we can run the validate script and give it the XAMS schema and the data itself, and it runs without any error message, which means it validates. So empty XAMS here in this case validates. So let's quickly check that this actually did something. Let's introduce something bad, something wrong, and run it again, and here you see that the element here false. This element is not expected. So this was against the schema here. It is good to, when you set up your node, to keep this in mind, to see, look at validation errors along the way as well, and see, and to catch them early, unless so you don't have to look at too many of them in the end once you have your node readily set up. Okay, after validation, let's put some data in our database. So we updated the model slightly since the last tutorial about the model. So basically, we changed the IDs to make them autofields which automatically increment, and we added the unique keyword to the character field, for example. But no big changes here, still a species, states and transitions data model here. And then we have some fake data in a small comma-separated value script file, I mean. So we have 3 columns, 4 rows. First one is a species name, an atom, a state energy, and a transition. So we open a Python shell and import our models and loop through the lines in our data file that we just looked at. We split it at the comma, and then we just say create a species, create or get a species object with the name of the first column in our line. So the first entry in this split line here is the first column, which means it's the magnesium, for example, the MG string that you saw earlier in the file. And something was wrong here. It was just a typo. So this runs now and returns 2 things, the species object and true, which means that it was created actually. It wasn't received. So if you want to catch this intercept variable, we call this is new here, and then we can access species name, species ID, and so on. And you see some other attributes here that each species object has by default. By calling species.save, we save it into the database. So you can create objects in the shell here or also in the script, of course, without saving them. So only when you call save, they actually saved into the database. And now we select all. We see three species were created, and those were the ones that were in our file. We can run this several times. There is no duplication since we use get or create. So when it sees, okay, there's already one with this name, there we don't need to create it again. Let's do the same thing for the state, and we use as the species attribute, as the species field for the state. We use the species variable that species object that we just created, so we can connect the state directly to this species here, and we give it the energy from the first column here, from the second column in the file. And we can looping through the states, we can see that their energies were correctly read in. Remaining are the transitions, so we again do get or create, and this time the third column, and use the state as the upper state in this case, and look again which ones are there. Okay, they are there. Let's look into the database, how they ended up in there. So let's start MySQL again. So I closed, this was quick, but I closed the Python shell. I saved the objects at the end, and now open the MySQL shell to select everything from the species table, for example, and we see the three species and the states. We see the corresponding species ID. So we have magnesium has two states, for example, as it was in the original ASCII file, and their IDs and energies, and the transitions that they reference. The upstate ID, we haven't set the lower state ID because it wasn't in the file, but of course you can expand this as much as you want. This way to put data into the database is a good way if you have small amounts and little data with few columns, to do it by hand like this. There is an infrastructure and some helper scripts in the Node software included. These are documented separately. There is, even if you have large amounts of data, it makes sense to rewrite them first into a ASCII format that can be read directly from the database. This will speed up the import into the database. So once you have over, say, a few gigabytes of data, it makes sense to set this up, this import up in a different way than I just showed here. But this is documented in the Node software documentation, and I refer you to that instead. This was a quick manual example that we went through here. Okay, let's run the query again, and now you see actually the HTTP headers are correct as well. We received 3 species and 4 radiative transitions, so that worked nicely. And if you look at the XML output, you actually see at the end here the transition wavelengths. They have a unit already. I set this up in the dictionary without showing it in the previous tutorial. So let's have a quick look. You can, each quantity has each dictionary keyword that is an actual data value of the data type has also keywords that describe the unit or comments or accuracies and so on. And in this case, we just set those as static strings, so they get just returned without looking into the database here. Okay, that's it. Goodbye.